Okay, now we're going to put it all together with that library of functions. What we're going to do is we're going to graph piecewise defined functions. So we'll have a bunch of them kind of in one function. Piecewise defined function just means we've got a function defined in pieces, and the pieces are where we graph the pieces are dependent upon where we're splitting up this independent axis. In this case, we're going to split up at 3 spots. And this is the way I kind of think of it. I've got x is less than -1. Well, here's the x-axis. When is it less than -1? Well, it's less than -1 this way. So anywhere kind of over here in red, like just this area, okay? I'm going to graph this function, okay? I'm going to graph that one, x squared, okay? Now, anywhere, let's say between -1 and 2, between -1 and 2, so this kind of area, if you will, that's when x is between -1 and 2. I'm going to graph this function. And then, well, what's left? X is greater than 2, that's to the right of 2. Okay, x is the x-axis, to the right of 2, greater than 2. Okay, I'm going to graph x cubed. In this case, we'll do it black. So this kind of area out here, okay? Okay, so the way I kind of do this is I just say, hey, look, what's x squared look like? Well, we know what x squared looks like. It's one of those graphs in a library of functions. We know that it kind of emanates from 0, 0. It's got this vertex here, and it's got a point -1, 1, and a point 1, 1, a point 2, 4, and a point -2, 4. And so we could graph it. I've got these points already plotted, but I only want to graph it when x is less than or equal to -1. So don't graph it in the blue area or the black area. Pretend you're graphing it. Okay, I'm not graphing it, I'm not graphing it. I know what it looks like, but I'm not going to put my pen to the paper just yet until I get into that red area when x is less than or equal to -1. So now I've hit x is equal to -1, and so I'm going to continue to graph it. And so I graph my function only in the red area when x is less than or equal to -1. -1 less than -1. X-axis, -1. All right, now I graph my function f of x equals 2x minus 1. Well, 2x minus 1 has y-intercept -1, right? Up 2 over 1, I'm going to graph right there. Up 2 over 1, right? If I was just doing these points, up 2 over 1, I'd be graphing a line that looks like this, right? And it'd be down 2 over 1, okay? But I'm only going to graph it in the area that's blue. So in this case, I'm only graphing it when I'm a little bit to the right of -1, all the way up to 2. So I've got this hole right here. And why is it a hole? Because it's not equal to -1, it's just barely to the right. And then I kind of graph it, keep going until I get to this part. I'm not going to graph it to the right of 2, and I'm going to put a big solid dot right there, okay, which represents that, yes, at the point 2, my height is 4. What do I have here? Sorry, at the point 2, my height is 3. Sorry, 1, 2, 3. Very good. At the point 2, my height is 3. Looked like it was in between from the angle. Okay? Now, does that correspond to what this says? Well, sure. If I plug in x equals 2, I don't use this function. 2 is not less than or equal to -1. 2 is not greater than 2. 2 is between -1 and 2 inclusive, so it follows in here. 2 times 2 is 4. 4 minus 1 is 3. So my height is 3. Okay? So I only graph the blue function in this kind of blue area, okay? Between -1 and 2. Finally, I graph x cubed. We know what x cubed looks like. X cubed looks like that kind of S-shaped deal, okay? And we know that it has a point 0, 0, okay? We know it has a point 1, 1. We know it has a point 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Wow, up here. And so forth. And it has, some other points down here. -1, -1. -2, 8, way down there. So if I graph this thing, I could graph it, but I don't want to graph it right here. I'm not going to put my pen to the paper until I get to the right of this blue line. Boom. And I should have saved myself a little bit more room. And it goes vertically that way. Okay? It goes vertically that way. It was not a very good choice of depth perception here. Okay? But I'm only graphing, so again, I've got this function, it's coming like this, it's coming like this, don't graph it, don't graph it, don't graph it, don't graph it. Now start graphing it. Okay? So that's graphing a piecewise defined function, okay? Is we look at it in terms of pieces and use those pieces independently So I graph x squared over here, and I'm graphing 2x minus 1 here, and I'm graphing x cubed over here, and putting them all together, right? Okay, so we're going to talk about the vertical line test. What is the vertical line test? Basically, it's a test that allows us to be able to check to see if the graph of some type of curve in space is actually the graph of a function. It's actually a great test. It's really simple, and it should make sense to how we've talked about whether or not something is a function or not. Again, to be a function, every first component has to have exactly one second component. The way we kind of remember that is we think of boys as first components and girls as second components, and we have this rule that boys can't cheat. So again, for every one x value has exactly one y value. It does not have two. Okay, so let's take a look at a couple examples that kind of this explains, and we'll go through this in just a second. Suppose I have a function that looks something like this. Okay, it's some curve. It's a happy little curve in space. So there's a bunch of x's, and there's a bunch of x's on this x-axis. There's an infinite number, and this curve goes infinitely left and infinitely right. So there's an infinite number of points on this curve. Well, does every single x value have exactly one y value? Well, yes, of course, in this case. Why? Because it passes the vertical line test. Well, what's the vertical line test say? It says a curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. So what we can do is simply just do this. Draw a bunch of infinite vertical lines. So I'm going to draw a bunch of infinite vertical lines, right? And ask yourself, how many times does each one of these vertical lines touch the graph? Well, you can obviously see in every case it's only touching exactly once. It's not touching twice, okay? It's touching exactly once, okay? It could touch zero. Zero is fine too. It just can't touch more than once. In this case, it's touching exactly once. So this is the graph of a function because it passes the vertical line test, okay? Now, why is the graph of this circle here not a function? Well, number one, it doesn't pass the vertical line test. I can find a line. Can I find a line that intersects a vertical line that intersects the graph more than once? Yes. Boom, there's one. And that should make sense on y, right? Well, this vertical line touches this circle in two spots. Well, what are the coordinates of this? Maybe this is the coordinate, I don't know, 1/2, say, the square root of 3 over 2, right? That's a coordinate. And maybe this point right here is the coordinate 1/2 negative the square root of 3 over 2. Well, here's the question. Does this x value have exactly one y value? It only has two. 1/2 has root 3 over 2, 1/2 has negative root 3 over 2. Because in this case we would say that the boys are cheating, if you will, okay, then this thing is not a function, right? So this thing is not a function because it does not pass this vertical line test. I have one x value corresponding to two different y values, and that's not something we're allowed to have to be a function. So in this case, this is not a function. Okay? What about something like this? What about a parabola turned to its side? Well, we like parabolas. Parabolas are good, but in this case, this parabola is turned to its side. So our question is, again, is this the graph of a function? Well, I say no, and again, the reason I say no is we draw a vertical line. Can we find a vertical line that touches twice? Yes, we can. So we have one x value that has two different y values, so no, this is not a function. Okay, not a function. What about just a simple line? Was that a function? Yes, it is a function. Again, it passes the vertical line test. Every vertical line I draw, no matter which vertical line I draw, at most it's going to touch the graph of that thing once. Okay? So that's the vertical line test. It's a very, very simple tool that allows us to be able to determine whether or not the graph of some curve is in fact a function.